Right now, modern artificial intelligence runs on massive industrialized server farms. We have built incredibly capable systems, but they rely on brute force. They are throwing sheer electrical power at a problem that human evolution solved using only 20 watts of energy. To train just one of today's top-tier AI models, a company has to use roughly the same amount of electricity that an entire small town consumes in a year. It is easy to overlook that scale. When we type a simple question into a familiar chat interface, we don't see the sprawling physical infrastructure burning through megawatts of power just to generate a text response. Our machines are mimicking human intelligence, but they are doing it in the least efficient way physically possible, and that inefficiency is becoming a serious problem. For the last few years, the strategy for making AI smarter was straightforward: build a bigger computer and feed it more of the internet. Researchers call this the scaling era. But that strategy has run into a physical limit, known as the data wall. AI developers have practically exhausted the supply of high-quality, human-written text available online. There is simply not much left to feed the machines. At the same time, they are hitting a compute wall. The financial and environmental costs to run these massive models are growing at an unsustainable rate. This chart shows how computing costs and energy use are spiking exponentially, while the actual intelligence gained from that massive investment is aggressively flattening out. The system is giving us diminishing returns. Adding more supercomputers is a dead end. To get machines to the next level of understanding, researchers realized they need to change how the machine actually processes information. That is exactly what the research team at Meta decided to do. They stepped away from the brute force method of feeding endless text into servers and started looking directly at human biology. They built a new system called Tribe V2. Unlike standard AI, which tries to guess the next word in a sentence using statistics, this new system is fundamentally designed to directly mirror how a human brain physically reacts to the world. Instead of scraping millions of web pages, the team trained this model on over 1,000 hours of direct human brain recordings. They didn't rely on rigid laboratory tests. Hundreds of volunteers were scanned while simply watching movies, reading books, and listening to podcasts. This captured how our minds naturally react to everyday, continuous experiences. By learning directly from these biological responses, Tribe V2 moves past statistical word guessing. It learns the actual mechanics of human perception. What this system produces is a highly detailed, real-time map. It predicts exactly how 70,000 distinct units of the human cortex will react when exposed to new information. Even more impressive, it can do this for a completely new person. Show the AI a brand new video, and it will accurately predict how a stranger's brain will respond to it, region by region. This essentially gives scientists a working digital twin of human cognition. Researchers can instantly run thousands of brain experiments in software without needing a physical MRI scanner. It is important to be clear about how this works. Think of this as a one-way street. The system looks at a video and predicts a brain's physical reaction. It doesn't work in reverse. It isn't reading your inner thoughts or looking inside your head to see exactly what you are thinking. What it does provide is a proven biological map of how humans process information. And that map gives engineers the exact blueprint they need to build much better hardware. Current AI chips waste immense amounts of energy because they perform continuous, dense calculations across the entire processor. The human brain works differently. It is sparse. It only routes energy to the specific circuits needed for a specific task, precisely when they are needed. Because traditional computing hardware is built for continuous, heavy math, it is physically incapable of mimicking that sparse biological efficiency. To fix this, engineers are designing new hardware called neuromorphic chips. These physical processors are engineered specifically to behave like human neural networks. Until now, we had these brain-like chips, but we didn't know exactly how to program them to act like a real person. By showing us exactly which brain circuits fire and when, Tribe V2 provides the blueprint engineers need to route signals through these new chips correctly. By pairing software that maps human perception with hardware built to mimic human biology, the tech industry finally has a realistic path out of the AI energy crisis. The era of winning the AI race by simply building the biggest data center is over. The real advantage now goes to those who can build machines that truly match the way our minds process the world. We are stepping away from brute force machines that rely on rote memorization and entering the period of grounded, highly efficient design. The template for the most advanced computing system humanity will ever build isn't sitting in a massive, power-hungry warehouse. It is already functioning perfectly, running on just 20 watts right inside your own head. Right now,